Assalamualaikum warahmatullahi wabarakatuh. Salam UiTM di hatiku. We are from program code AS120 and today we'll be presenting to you about application of electricity and magnetism in information and communication technology. We are going to explore how electricity and magnetism make modern communication possible. Before we go into the detail, I will start by introducing what ICT is and its significance in our daily lives. What is ICT? ICT stands for Information and Communication Technology. ICT plays an important role to make information accessible. They also improve speed and efficiency of information transfer. Next, ICT also support modern systems like online learning and e-commerce, which is the buying and selling of goods and services online. Last but not least, ICT is crucial in order to connect people around the world using communication network. Now, let's look at physics principle behind information and communication technology. ICT mainly relies on electricity and magnetism. Electricity works as power circuit inside communication devices. Changing electric and magnetic field produce electromagnetic wave for wireless data transfer. In ICT, we mainly use radio wave, microwave, and sometimes infrared for data transmission. So, here is how information and communication technology has evolved over time. The journey of ICT started a long time ago, back in 1830s with the invention of the telegraph. It was the first long-distance communication devices that works by sending coded signal through wire. Then, in the 90s, came radio and television. These technologies introduced to the use of electromagnetic waves to transmit sound and image wirelessly. For the first time, people could communicate and receive information instantly without using physical wire. Fast forward to the 1990s and we enter the age of the internet. It is the beginning of global digital communication. And today, we have fiber optic, Wi-Fi, 5G, and satellite, which represent the modern era of communication. All information and communication technologies rely on these basic physics principles. First, we have electric current. The symbol is I, represent the flow of electron that powers every electronic devices that we use. Next is a voltage. The symbol is V. Voltage is a push that drives the current through the circuit. We have resistance, which is represented by the symbol of R. It controls how easily current flows. These three are related by Ohm's law, which is the current flowing through a conductor is directly proportional to the voltage across it and inversely proportional to the resistance, or V equals to IR. So overall, this shows how physics applies in real-life communication technologies.
Okay, my name is Raihani Binti Aziz, and now I want to continue about the electricity in communication device. So, electricity is the foundation of all modern communication system powering devices such as smartphone, radios, television, routers, satellite, and computers. So, communication devices rely on electrical energy to convert message into signals and transmit them over distance and convert them back into understandable information. Next, why electricity is important in communication system. So first, electricity is the powers all communication device and it converts information such as sound and data into electrical signals, and it enables the transmission of signals through wires and networks. And also, electricity allows device to process, encode, and store communication data. Okay, so how information travels in the communication system. So first, the device converts sound, image, or text. For example, like camera turns light into the electrical signals, and then the signals travel through the wire as the moving electron. Then the signal is carried through the cable or air to the receiver. And lastly, the device changes the signal back into the sound, image, or text. For example, like screen use the electricity to show picture or text. So this information travel is related with the power formula, which is P equal to IV. So I is electric current, rate of electron flow carrying the information. V is voltage. Voltage is electric potential pushing electron through the circuit, and P is power, energy used by the device to process and transmit the signal. Now, the real life example of the communication device. So first is smartphone. Smartphone use the electricity to power internal circuit, processor, cameras, and touchscreen. Second is computer. Computer use the electrical energy to process data, run application, and transmit information through network. Third is speakers and earphone. It converts electrical signals back into vibration that produce sound for music, calls, and videos. And fourth is Wi-Fi routers. It converts electrical signals into radio wave for wireless communication between devices.
I will be talking about magnetism and electromagnetic waves in communication. Communication systems depend on electromagnetic waves to send information wirelessly. Wireless communication like radio, TV, Wi-Fi, and satellites rely on electromagnetic waves, also called as EM, to carry information through space without wires. These waves can travel long distance and carry signals for voice, video, or data. Magnetism is deeply connected to electricity. Whenever an electric current flows through a conductor, it produces a magnetic field around it. Magnetism cannot be ignored because it is fundamental component of electromagnetic waves. Without magnetism, electromagnetic waves could not exist and all forms of wireless communication would collapse. EM waves carry energy without any medium. Unlike sound waves that need air, EM waves can travel through empty space, vacuum. When electric current changes, it creates changing magnetic fields, thus creates EM waves. For the equation, it is C equals to F lambda, which means speed equals to frequency times wavelength. For examples, radio and TV use radio waves for broadcasting. Wi-Fi and Bluetooth use microwaves to transmit data wirelessly. And lastly, satellites and radar use radio waves and microwaves for long-distance communication and detection. Advantages of using electromagnetic waves in ICT. It enables wireless communication. In other words, no need for physical cable. Second, it is fast and reliable transmission of information across the world. And lastly, it can travel through vacuum, suitable for space communication.
Now for the next topic, which is fiber optic communication. First, let us begin with the basic idea. Fiber optic communication is a modern technology that uses light waves, which are part of the electromagnetic spectrum, to transmit data. So instead of using electrical signal through copper wires, fiber optic transmit information in the form of light pulse through extremely thin strand of glass or plastic fiber. Each light pulse represents digital data, such as 1 and zeros. Because light travel much faster than electrical signal and experience less resistance, fiber optic communication allow data to be transmitted at a very high speed and with greater efficiency. So, how does fiber optic communication work? Alright, the key principle behind fiber optic communication is total internal reflection. Okay, when light travels from a medium with higher refractive index to a medium with lower refractive index, and the angle of incidence is greater than the critical angle, the light is completely reflected back into the core instead of reflecting out. So, as a result, the light signal continuously bounces along the fiber, allow it to travel long distance without escaping. Okay, so this process involves several important physics concepts. The first one is refraction. Refraction occurs when light changes direction as it moves between different media. The second one is reflection. Reflection occurs when light bounce off a surface. And the last one is refractive index. Refractive index is a measurement of how much light slow down in a material and can be calculated using the formula of N equal to C over V, where the C is the speed light in vacuum, while the V is the speed of light in the medium. To conclude it, a higher refractive index means light travel more slowly in that medium. Now, by using fiber optic communication, it offers us several advantages. Firstly, it offers very high transmission speed, making it ideal for high-speed internet, video streaming, and cloud computing. Second, a fiber optic can transmit data over a long distance without minimal loss, unlike copper cable which require frequent signal booster. And the third one is fiber optic cable experience low interference because they are not affected by the electromagnetic noise from the electrical device. And in addition, fiber optics are more secure as it is difficult to tap into the signal without detection. Actually, without we all notice, fiber optic technology is widely used in our daily life. For example, it's formed the backbone of high-speed internet and broadband networks, which permit fast and stable connection. Next is the undersea fiber optic cables, which connect continents and allow global communication, internet phone call, and data transfer. Other than that, in medical field, fiber optic are used in endoscopy and laser surgeries, allowing doctor to see inside the human body with minimal invasion. Fiber optic are also used in telecommunication, cable television, and data centers. So there are lots of application in our daily life. Now, why is fiber optic communication important? Alright, the impact of fiber optic on society is very significant. First, it improves global connectivity, which allow people from different parts of the world to communicate instantly. Second, it supports digital education that include online learning and virtual classroom. And third, fiber optic also enable telemedicine and remote healthcare, where doctor can diagnose and treat patients from a distance. Furthermore, it plays a crucial role in business, banking, e-commerce, cloud computing, and data centers, making modern digital life possible. So, in conclusion, fiber optic communication is not only key technology in today's world, but also a foundation for future innovation. With high speed, low loss, security, and wide range of application, it will continue to revolutionize how information is transmitted across the globe.